Dear learner, welcome to our today's class. I am beginning by the chapter indices. My name is teacher Fidelis. Indices. I'll be doing some examples from the previous kcse questions, but before that, it is very important for you learner to note the following. These are some few basics concerning the indices that you should have in mind before assuming that you can solve these questions concerning the indices. The first basic is any number, for example, any number A raised to the power 0, it will simply give us a 1. What do I mean? If I pick 1 million and raise it to the power 0, it will simply give me 1. If I again pick the least number, for example, 1 raised to power 0, it will simply give me again 1. I can try to write it with a space so that you can know the difference. 1 raised to power 0 gives us a 1. Higher. The second basic, it is on the multiplication and the addition of indices. That will go again hand in hand with the addition and the subtraction of indices on the power. What do I mean? Now you have a number A raised to the power Y multiplied by the same number A raised to the power X. What does this mean? This simply means that the same number that repeated itself, it will be on the answer side, but the multiplication means you simply add the powers. The first power was Y, the second power was X. So what does this mean? When I say that the multiplication and the division goes hand in hand with the addition and the subtraction, and it comes to the indices. This is what I mean. When you have a question that has a number raised to two different powers which are separated by an addition, it simply means that it was extracted from the same number raised to the first power multiplied is representing the addition on the power, multiplied by the same number raised to the second power on the number. We'll see some examples that use this trick. Let us visit the division. Division, let's assume we have a number A raised to the power Y divided by a number A, the same number A, raised to the power X. What does this mean? This simply means that you are going to have an answer with the number, and the division will mean subtract the powers. Pick the first power, which is Y, subtract the next power, which is X. So when you come across a question with a number raised to two different powers separated by a negative sign, it means that this originated from what we have written first here. But the addition and the subtraction of the powers only applies to numbers with the same base. And the last basic, I can write it there. The last basic, what does it mean? What does it state? If you are unable to express all the numbers, in an equation, if you are unable to express all the numbers in an equation, You can rub these others so that you can simply see the last basic in a good manner, in a good way. If you are unable to express all the numbers in an equation using the same base, let it ring at the back of your mind that you are going to opt for the letting method. What do I mean by the letting method? The letting method is let, for example, let 5 to power 2x be y, let 9 to power 2a be b, vitu kama hizo. That is what I mean by this. It is a basic, it is not a law. That is what should be with you before tackling an indices. Now, let us see some examples from the previous kcse questions. When it comes to a kcse question, it means that you are going to apply all the formulas that you've tackled in Form 1, Form 2, Form 3, and Form 4, even though the indices is a Form 2 question. Some of them will need to use some concepts you will learn even in further chapters in Form 2. What do I mean? Let us see. Question 1. It is a question from the year 1995, and it was even worth 4 marks. It says 49 raised to power x plus 1 plus 7 to power 2x gives us a 350. Before we even continue, the least base here is 7. We know 7 is the same as 7 to power 1. Can we express 49 in terms of 7? Yes. 49 is simply 7 times 7, which is the same as 7 to power 2. What about the 350? The 350 means the 350, can the 350 be expressed in terms of 7? You'll find that this is an impossible number. It can be expressed using this format. What did I say on the last basic? That if any of the numbers cannot be expressed using the same base, like in our equation, all the numbers were using the base 7. 49 got the base 7 to power 2. 7 got the base 7 to power 1. But the 350 chose not to use the 7 base. So that means that in our equation, we'll have the letting option. What do I mean? Let us first express the 49 as a 7. The 49 as a 7. So that we can know what we are going to let. 49, we have said it is 7 squared. But the 49 had a power, which is x plus 1. If we choose to put it so barely, the 2 will only multiply the x. It is important to put the bracket sign there to show that the 2 multiplies everything in the bracket. Plus 7 to power 2x gives us the 300 and what? 50. Gives us the 350. Let us also do this bracket. 7, what is 2 times x? It simply gives us the 2x. The sign is plus. 2 times 1 gives us a 2. Then again, we continue with the equation. It is said plus 7 to power 2x gives us a 350. Which unknowns do we have in the equation? But even before knowing the equation, the unknowns we have in the equation, there is a basic I gave on the addition of powers. This simply means that the 7 to power 2x plus 2 simply means that these were two numbers with the base 7. And the two are separated by a multiplication sign because of an addition on the power. So the first number was 7 to power 2x multiplied represents the addition on the power, 7 raised to power 2. So we can choose to replace that on our equation. So instead of now using this, we are going to replace it with the broken part so that it can be better. Let us see what we'll have. This means we now have a 7 to power 2x multiplied by a 7 to power 2. This was initially the 7 to power 2x plus 2. Then plus the 7 to power 2x, giving us the 350. Which unknown do we have here? 7 to power 2x. So, what are we going to let? The unknown. Let 7 to power 2x be, for example, A. Now, whenever you have a 7 to power 2x, where there is a 7 to power 2x in your equation, replace it with the unknown A. Now, this is a 7 to power 2x, so it will be A times 7 to power 2 plus A gives us a 350. Good. Now, what is 7 squared? 7 squared means the 7 times 7, which is 49. So this is the same as A times 49 plus A gives us a what? 350. What is 49 times A? This simply becomes 49 A plus A gives us a 350. So many students have a problem on the addition of unknowns. Just assume that you are dealing with the fruits. For example, I have 49 mangoes, and a friend of mine adds me another mango. What is the total number of mangoes I have? 50. But assume that your mangoes were replaced with the unknown A, gives us the 350. What is value of A? We simply divide both sides by 50. So A gives us what? By 51 by 57. So A gives us a 7. 7 is simply the same as 7 to power 1. But what was our A? Our A was 7 to power 2x. See, it is true. We got it here. 7 to power 2x gives us a 7, and the 7 we have simply said it is the same as 7 to power 1. This is a basic I forgot to give. When you have same bases, for example, we have here 7, and on the other side after the equal sign we have a 7. When we have the same base separated by an equal sign, this simply means that the powers are equal. What do I mean? Allow me finish it on the further end. Allow me finish it on the further end. This simply means we have a 7 to power 2x is equals to a 7 to power 1. Why have we replaced our 7 with the 7 to power 1? Because our A either power. Our A either power. And the only way of expressing 7 is by writing 7 to power 1. There is no difference between 7 and 7 to power 1. Now, the 7 to power 2x is equals to 7 to power 1. Good to go. We have the same base separated by an equal sign. We have the same base separated by an equal sign. I have said that is a basic I forgot to give. When you have the same base separated by an equal sign, this simply means that the powers are equal. The first power is 2x is simply equal to 1. Now we were solving for the value of x. You divide both sides by 2 to get the value of x. So the only value of x we have is a half. Clear work. Clear work. Everything well elaborated. That is what mathematics needs. Goodbye, student. Goodbye, student.